without much further ado, let's get into the meat of this. So, childhood development and programming. It's probably not something that a lot of people think of together, but it's actually been around. The concepts of that have been around for quite a long time. You brought up in our chat this programming language called Logo, which was, I think, developed by MIT, and it's been around for, gosh, I want to say since what, like the 70s?
I think that's right. Yeah.
Yeah.
But yeah, and I tend to say Seymour Papert, but sorry, go ahead, Kristen.
I remember at a young age using Logo. So,
Same.
yes, since the 70s.
So, and Logo, for those of you who don't know, is kind of a Lisp spinoff, and ish. And it's basically kind of a programming language for kids, but it's more pseudocode-ish than real deep coding. It uses a lot more kind of natural language type things.
I have a lot to say on that one, but go on.
Yeah.
By the way, 1967.
67, so even a little older.
Yeah.
So,
yep.
But yeah, this is not a new concept, but I think it's one that I've never seen an interview or a talk show or anything or a podcast, listen to a podcast that talked about this concept. So I was really intrigued to get into this. So, why don't you start us off with a little bit of Logo and what it is and how that works, and then let's kind of expand on your views there.
Sure. So I mentioned Seymour Papert. He's written a couple of great books, and you can tell that a lot of people have read his books in our field because one of them is named Mindstorms, which is to say that's what that series of Legos was named for. Mm-hmm. And we'll talk about that as a bit later. So people knew computers were going to be big, and they figured out shortly after that, oh shoot, we have to teach kids about computers. We're going to get a computer in the classroom. What do we do? And just like computers move faster than almost any of society was ready for, and certainly if you wind back to the 1960s, that was still true. And so the teachers didn't have any idea what to do. And so Seymour Papert from the Learning Lab at MIT was one of the first people to sort of go, okay, we're gonna do this. Now, Papert was a student of Piaget. Piaget is one of those folks that most people have heard of but don't realize they've heard of, because he was the guy that studied things like object permanence. At a certain age, when the ball rolls behind the chair, the baby figures out that the ball's still there. It's just behind the chair, and we'll go look for it. Really young baby doesn't figure that out. Ball goes away, ball comes back. Baby's not surprised either way. They're used to objects disappearing forever or coming back at random, all the time. Like if you're a baby, that's just how it works. Yeah. But at some point, the baby figures out the ball's behind the chair. They'll go look for the ball behind the chair. If the ball's not behind the chair, they're going to figure out something's weird. That's where they get surprised about objects not continuing to exist, object permanence. And there's stuff like if you pour water from a tall thin cup into a short fat cup, at some point a kid figures out they're the same amount of liquid, and earlier than that they don't necessarily. You ask a kid who's young enough, they're going to say, oh, there's more in the tall thin one or whatever. So Piaget was recent enough. I mean, everything I said sounds like he could have been 1000 AD or something, but no, he was recent enough that a number of his students are still alive. That's how recent Piaget was. And in fact, Papert was one of his students. Several of the early computer folks, like Marvin Minsky, who was one of the big AI pioneers, was one of his kids. Very popular, was one of his students, not his kids. Very popular, Marvin Minsky, among Piaget's students, because he had twins, a boy and a girl. And he was one of a big group of people studying childhood development. Everybody wanted to go talk to Marvin Minsky's boy and girl twin. Anyway, yeah, exactly.
I know the feeling.
Yeah.
I've got twins, so.
Nice.
Yep.
All right, I will try not to get, off on that. There's a lot of fun stories there.
Oh, yeah.
I'll try not to get too far off track. Papert. So Papert was one of Piaget's students, which means he's against curriculums and the way classes tend to work and the way most teachers do what they do. And basically, he was an educational revolutionary. And they basically went to him and said, "We need a curriculum for computers." And so he's, kind of grinning behind his hand and goes, "Oh yes, we can make this work." Mindstorms, by the way, is the book about this. It's a really good book. So Papert, who's young and doesn't know what he can't do yet, and it's early in the computer revolution, and he's an engineer, and he doesn't know what he can't do yet, so he decides to do several things that are impossible, and he gets partway through several of them. It's awesome. He decides, you know what we're going to do is we're going to make a thing where you can learn mathematics the way you learn to speak French in France instead of the way you learn to speak French in a classroom. We're going to make a world that is like native math in the computer. And so Logo is the attempt to do that. And he's doing it in the computer, but he's not wild about the computer, partly because you've only got one computer in the back of the classroom. Whatever he's doing, you don't have a lot of computer time. So if you focus too heavily on the computer, you lose. And the cool thing about Logo, so you mentioned it's a Lisp derivative, which isn't quite how I'd categorize it. Logo's instructions are, you've got a little turtle there, and you can tell it things like turn right 30 degrees, go forward this distance, turn left 60 degrees, go backward, pen up, which means stop drawing, pen down, start drawing. Like it really is geometric. All of the instructions are geometric.
Mm-hmm.
The important thing about that, because you might say, well, like turning degrees, that doesn't sound like something kids are going to love. The important thing about that is you don't need a computer to do it. If one of you is writing a list of instructions, you grab another kid to be the turtle. And one kid reads the list of instructions while the other, yeah, there you go. You got it on the screen there.
Yeah.
One of you reads the list of instructions while the other kid is the turtle, which allows you to teach debugging without a computer. Because all you need is a paper list of instructions and the kid to go, oh, you moved the wrong way. No, you said turn 30 degrees. I turned 30 degrees. No, you moved the wrong way. Well, you look at the list of instructions and you figure out what the instructions should have been. Yeah, so Papert's fantastic. Papert does all kinds of cool stuff, but he also doesn't love curriculum.
And I remember doing this as a kid. I was involved in a thing called Odyssey of the Mind. It was kind of a competition of teams that from, like around the state that would get together and you'd do these different things for different STEM areas and compete. And one of the things that we did as a team, and this was probably 7th or 8th grade, I didn't realize what this was, but we basically did this, laid out a big grid on the floor with tape and we had a computer writing BASIC. We weren't using Logo because I didn't know that was a thing, but we were doing it in BASIC. And basically we had some person out there being the robot and we had to, program them to go pick up these certain things and end up in a certain spot. And so, we were doing this for real. I didn't know I was doing that, but, it's kind of cool.
Well, and you'll see echoes of it. One kind of obvious thing with kids and with childhood development and computers, not that we've talked about it yet, is how do you teach kids about programming? But there are some great sort of pre-programming board games. I don't know if you've got a copy of Robot Turtles or a much older one called Robot Rally.
If you like this clip and want to watch another one, you can click right here, or if you want to watch the full video, you can click here.